Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 144. Find the maximum number of fruits collected. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, I don't think this one is that hard. It is a 6-pointer. I think people just spent too long on Q3, and I did, to get this one, because 300 feels a little bit low for this problem. But I mean, I didn't solve it, right? So who am I to judge? But also, honestly, I didn't solve it because I spent all my time on Q3. I did not look at this problem until after the contest. And in retrospect, I should have, because I got it in about 25 minutes or so. And honestly, I got it within 10 minutes, but I spent 14 minutes debugging a silly typo/edge case thing. But yeah, so okay. So this one is actually, I mean, first of all, you need dynamic programming. I'm not going to go over the dynamic programming part in too much detail, honestly, because I think very similar problems are all over Leetcode. So once we get to that part, please, if you still don't understand the dynamic programming, you have to practice it. Like, if you just judge this by the dynamic programming, it is actually, like, I would expect that most people doing interviews should be able to solve and competitive as well, right? So I'm not going to go detailed about this one. Instead, this problem is about observations and kind of reading a little bit. It's a little bit confusing, but yeah. So okay, so well, first of all, let's say we're doing a naive dynamic programming. What would that look like? Well, naive dynamic programming may look something like n to the 6, right? So you have an n by n matrix. No spoilers. So you have an n by n matrix. So then you have three people. You have, you know, maybe x1 or x0, y0, x1, y1, x2, y2. And if you do a dynamic programming in this way, it is going to be too slow, right? N is you go to 1,000, right? So yeah. So then if you times each of the, you know, look at all the possibilities, it is going to be too slow. So what can you do? Well, the first thing that I kind of looked at was that, well, remember, you know, maybe another way that you could have thought about it, another thing that you could have attacked is noting that, okay, well, can we just do them 3 independent times and then add up the results, right? And the answer is no, because you have to keep track of where the other people took, right? Because you cannot take the same cells, because if you took the same cell, then that means that if you took the same cell, that means that how do I say it? If you took the same cells, you do not count all of them, is what I mean trying to say, right? You only counted the first time, so you have to keep track of state, and keeping track of state is not it's gonna go way poorly, right? So as a result, you're trying to keep track of all of these in the same time, and you get these things. So the first observation that I made, and maybe it's not the same order that people might have made or would have suggested, but this is the order that I would have, right? That I actually did during or after the contest as an upsolve, is that noticing what is the invariant, because in this one, the invariant is that they all take the same number of moves, right? So this is because we're trying to get to the corner, we're going to take exactly n minus 1 move. And so, okay, so let me take a note here, right? Every child will make the same number of moves. So then the first thing I did was look at these steps is, okay, so then after or maybe x is confusing, after k moves, where is each child, right? Well, yeah. And for now, looking at this may not be the step-by-step prescription, because look, when we all don't do things step by step, so this is the way that I did it, but I could also easily see people doing it the other way. But yeah, I just look at this thing, right, where, okay, so I to J, right? So here, let me just copy and paste this part, right? And yeah, so let's just look at these two child. Right, so looking at two of them, we had this choice, right? And here, I noticed that, okay, well, I will only go to I plus 1, right? So that means that, actually this is technically up here. So then now I can, after k moves, where's each child? Well, this child is at, well, because you add k times, this is going to be something like k and then some other number, right? And then this child is going to be at k, some number k, right? Because this can never change, right? Like after k moves, this will always be k. Here it can go up, down, and you could do some maths. Like maybe there's some max on, or min or max on the number. Like if you want to be precise, it could be like I minus k, I plus k, something in that range. But you know, whatever, right? That's okay, but that's not necessary. Okay, so then now, how do I think about this now? Well, now I thought, okay, well, there are moves. Now instead, so these are my initial dimensions, my dynamic programming dimensions. And as I said, if you don't understand what I'm going on with the dynamic programming, I'm focusing on this problem. You have to be good enough in the dynamic programming basics. So definitely, solve easier problems first, honestly, right? Like, don't run before you walk. But yeah, okay, so moves. So then now my dimensions, I'm thinking of, okay, well, we have XO, YO, moves, and maybe you could just say K in the same number, and then Y1, X2, K, right? So, okay, so now we kind of reduce this to this. And I go, okay, that's good. Now you can see that we only have 4 dimensions. Oh, sorry, 5 dimensions. So that's faster, but still too slow, right? Well, the thing is that, and then I was like, okay. But then the thing I noticed is that, okay, well, actually, if you look at this guy, the first child, the first person, right? If you look at this person, I mean, you could go, basically you're going, diagonal or down or right? But you have, the key is noting that everyone has to end up on the bottom right. Well, there's only one way for top left to go to bottom right? Because anytime you move around, you're just going to get off track and you cannot go to bottom right. And it is that this is diagonal. So actually, diagonal must be visited. And as a result, then now you just have this thing, and you can say that, so now our dimensions are up to here, right? And you just kind of do the math on diagonal. It's pretty straightforward. You just sum up the diagonal, right? And to make sure that, because it has to be visited, to make sure that the diagonal is not visited, you can probably do something, you can, I think for this problem, you could actually set the diagonal to 0, but you can also set it to negative infinity or something like that, and that'll be fine, right? Like it does. I think if there are negative numbers, you should do it to negative infinity, but if 0 to 1,000, it's fine, right? So yeah, anyway, but yeah, and make sure we don't visit the diagonals. So okay. And then the only thing that's left is that, well, if you don't visit the diagonal, the next part is just visualization, or like I don't think it is. I call everything pigeonhole, but I don't know that it's pigeonhole, but it's more that it is forced, right? And here I will bring up the drawing board real quick to see what is allowable, right? Okay. So without loss of generality, let's say we have we only look at 1/2, right? So let's say this is, I don't know. This is 5 by 5, right? Well, I mean, and you can do this in a reverse kind of way now, right? So this is for n is equal to odd. But the way that you think about it is that, okay, let's say we start here. What cells are possible? Well, we know that we have to end up here. So in a way, we can just go up, right? So we go up, but we don't know what's possible. But actually, you could do it in both directions, right? So that means that this will also go up, because this is like the farthest it can go, and then we reach here. So that means that in an obvious way, maybe these cells can never be reached, right? So we don't have to consider them. I mean, that's pretty obvious, maybe, right? And also, then now, what about these cells, right? Well, these cells are also not reachable. Why are they not reachable? Because you have to get back down, right? Like if you're here, if you just go right and then you go down, you don't end up all the way here. So you're forced to end up here. So go ahead. So that's basically the idea, right? So then now you have this thing. And what does this mean? Well, that means that, and we know that the diagonal it's used to, so this is actually 0, so you don't even want to be there. Maybe you could say negative infinity to make sure that we don't visit the same one. So that's just semantics, right? Because you have well, you can't do negative infinity on the corner. So except for the corner, you do negative infinity. But the idea is that to set negative infinity would be that you force each person to not choose the same thing, but that's fine. But anyway, yeah, so here, if you're forced to not go diagonal except for the very last square, so that we can, because we know that these are taken, and because everything else is positive, then we should just go before. But as a result, keeping in mind that if you're here, let me change the color. If you're here, you don't, even though you don't touch the diagonal, if you go above this point, there's no way for you to get back, right? So that's basically the idea. And as a result, we only have to consider this box, right? Because everything on top, we cannot visit, right? Because visiting it won't allow us to get back to the corner. And then now, without lost generality, you can flip it to the other side, right? So, right. So let's say we have this thing. I wish there's an easy way for me to shrink this. Does this work? No. Like I want to kind of just make it smaller and then write bigger on top of it. I need a bit different program maybe, but oh jeez. Okay, so you have this thing, right? All right, I guess one way that I can do it is just... Huh. I was going to flip this, but I don't know why it's not flipping. Okay, now it's gone. Okay, let me just draw it again real quick. Okay, whatever, I'll just draw it like a smaller version, right? So we have this, we can only go, let me actually just draw the box, right? We can only go here and technically here, right? And then now, if you kind of, you know, if you have this, okay, so I flipped it twice. That doesn't... How do you do a rotate with flips? I thought this is how I do it, but no, I just did a transpose. Okay, whatever. Sorry, friends. Technical difficulties. But yeah, but if you kind of look at it... Alright, let's just use a different color. So if you look at it from here, though... then now you see the same thing, right? So you kind of see it this way, right? Because in the same way, you could just kind of flip it, right? You see that this, and this, right? So this is the thing. So then now you draw the line this way. And the thing is that the key thing to notice is now that there are no overlaps, right? The only overlap is at the very end. And that's it. There are no overlaps. And what does that mean? If there are no overlaps? If there are no overlaps, it means that you could do them independently, right? So then now, even though I was tempted, I mean, it's kind of weird because now I said all these things, but it turns out that the K, it's a little bit of a misnomer. It doesn't even matter. It just means that now we can do them independently. And as a result of doing them independently, yeah, that means that child 2 and child 3 is just 1,000 square each, because they're only 1,000 square cells. In fact, it's smaller than that, but yeah, that will get you through, and that's basically the idea. And okay, so I wrote 2 DPs. I kind of was a little bit lazy. You could probably generalize a little bit, but even though I still managed to mess it up, but it was pretty fast. Yeah. Here we take care of the diagonal. I set it to -infinity so that we don't visit it. Actually, it should be fine for us to visit if it's not optimal. So we could even set it to 0 and would be okay. Yeah. I put a Y here for some reason. But yeah, this is the DP for going right. This is pretty straightforward, honestly, right? Where best is your -infinity. We have to go right. So we go for each dx, which is up, down, or yeah, up, down, or just straight right, up right, or down right? So we do these 3 things, and we take the path that is the best, and then we just return best. Pretty straightforward DP. For a grid DP, again, I'm not going over it that deeply this one, but it shows up in a lot of Leetcode problems, so definitely you need to practice DP if you don't know this part. The observations that were more important for me to go over. Going down is the same thing, right? You're just going down, but now you have a dy instead. So we check for going up, we check for going down, and then we check for diagonals, and that's pretty much it. This is going to be O of n times, n squared times, right? The size of the input. So it's linear in the size of the input, which is a weird way of saying it, but even though that is n squared, because there's n squared number of inputs, right? Because for each one, we only go down 3 things. So this for loop is O of 3, assuming that each of these is cached. And as a result, this is going to be O of 3 times n squared. So this is going to be O of n squared. Same thing here. And that's pretty much it. Yeah, I'm going to make it slightly smaller so you could see it on the screen. And yeah, that's pretty much all I have for this one. Let me know what you think. The hard part is the observations, so definitely, yeah, check that out. Thanks for watching, and yeah, you can watch me solve it live, well, up solving it after the contest. Next. Okay, I am just dumb. Alright, up solving. Alright, just making sure no one spammed too much on it. Up solving, let's do Q4, 300 pure got it. Can I do it? And this is a new up solve, so I didn't peek enough. I should have. This is my worst finish, I feel like, in months, but maybe I could have done this. Alright, focus. I mean, it doesn't matter, but I'm so tired. My eyes, I can't even keep my eyes open. But alright, let's go. End by end grid. And there's an animated GIF. Alright, so, okay, you start at 0, 0. Okay, so the 3 corners. So the upper left can go in a 3 direction toward the whatever. So there's a million. Maybe I have to reread this. N minus 1, right? So they all want to meet at this thing, at the right corner. Okay. Let's actually read the rules, double check. What is J minus 1? Oh, left. What does target room exist mean? In that order, or what is it? Oh, I mean, it's not out of bounds, so it has to go down, and then just left, down, right? has to be finished at the end. Dun, dun. So the invariant is that they have to reach the room at the same time, right? So what are the indexes? For example, this one. Okay, so there's moves. Moves determine 2 of these things, but there's still 1,000 of them, right? So then it's going to be 1,000 times 1,000 times 1,000 if not careful. Oh wait, what do the fruit mean? Oh no, that's fine. That is what n by n means. Okay. So they are 1,000,000 cells. Okay, just want to make sure. And wait, it's a square. Okay, it's a square because it needs to be for the symmetry reasons. I mean, is this though? Am I right on this? Like this is a lie, isn't it? This is a lie, and that's why this... Okay, so this is not that bad, because this is a lie. I would have gotten this during the contest. This is a lie because it only goes diagonal. Even though it was trying to do... Okay. Yeah, okay, go. Well, no, it's still n cubed though, because it's the moves. Okay, maybe I won't get it. Let's see. Okay, so we know that this is a lie. The moves determine this uniquely because you can only go diagonal. So it's only this and this, which has n square states, which is fine, but then you also have moves. I mean, I know it's not a full n square, but it's still... Can I bound that a little bit? Well, you cannot go beyond the diagonal. Oh, because you cannot go below the diagonal. The moves are independent. Okay, yeah, I should have gotten this. You never go you always miss the diagonal anyway. Okay, I see. Yeah, okay. Yeah, I mean, this is trivial. I should have gotten it. I guess I should have skipped ahead. Okay, fine. I see. Alright, what am I doing? Or how am I going to do it? I want to do it recursively, but I feel like Leetcode is always kind of messy on the recursion, but we'll just do it, right? So go right. Okay, so we have this, and then now we're just going up, right, and yeah. And we don't want to do the diagonal, right? So actually, yeah, we could undo the math. Yeah, this is. Oh, wait. This is no, this is TX, Larry. You suck. Also, why would you not remember the cache? Okay, but what we want to write is my neighbors are being loud, but you know how it is. I mean, this code doesn't even make sense, but okay. This is. I don't know how long I'm taking on this one because I'm not, but it is what it is. Because I didn't really track it that well. What is this code that I'm writing? I mean, luckily it would not run, but also I forgot to check the bounds, right? So. In my timeout or whatever, but oh, this isn't even right. Alright, well, that's a fun challenge, I guess. Is that a thing? I forget what it's called. Cache queue. Okay, I just wanted to do that. I didn't add the score, that's why this is wrong. It is, and this is also copy and paste dumbness. But this is plus. What's my base case? So this is 0. Let's make the base case foot. So no. This is 0 because it's on the diagonal. Otherwise, though, actually should add foot. I guess we can just add it here. I don't know how long this end up taking, but but it is wrong, so I spoke too soon. I'm kind of confident about this though. I mean, maybe just typo because I rushed it, but yeah, I feel like this should be right. My answer is better than the answer, so it's really not great. Debugging is going to take long though. I think the idea is right. I'm just kind of rushing it, like I said, and that's kind of not Gucci. Oh, I know, because I choose 0, so let me take a path maybe? I don't know. Let's see. No, that's still... Okay. This is so hard to debug though. Like, what are you gonna do? Am I going the wrong place? Go down from 0, 0, no, this is fine, I think. Especially now that I fixed the diagonal. Okay, I mean, even in whatever, we cannot get a brick. Okay, so you have this. This is going to be 4, 13, 12, 4, right? So what is that? 25 plus 8 is 33. 43. Do I double count something? I'll write it down. 69. We have 89. Probably 19, 16, 16. So what is that? That's 32 plus 37, 67? No, 32. Oh, no, 69, sorry. 32 plus 37, yeah. 69, so okay. Not so nice for me, but okay. So why is this wrong? Did I still have a typo? Go right is wrong. X plus dx. What? Yeah, why is that wrong? You have to get the 4. Go right. It's going to be on the last one. 0. Okay, 4. How do you get higher though? 25 times 8 plus 8. Yeah, I think I did the math wrong on that one. Is there even a way to go higher? I don't even know. Like, how would you go higher? You're here? Huh? I mean, I have a typo somewhere, I think. This doesn't even make sense. Oh, I'm just really bad at math. Okay, I mean, I guess you have to print. Just one of those days. Okay, so 3 should not be whatever. Oh no, 3 is fine. Wait, what? Oh yeah, 3 is maybe fine. Oh, because you could go past when it's not diagonal. You could go like from 4 to 16, so maybe it jumped around. No, but once you cross, you can get back, right? Alright, let's see. 4, 0. Okay. 1, 3 is 12. I mean, okay, that's fine, but you can't get there. So what is the 4, 3? 4, 3 is 4, that's fine. And then 4, 3, 3, 2. 3, 2 is 26 as well. Oh. Three, 2 is 26 because it's 14 plus 12 plus 14. But why? Because it cannot get to n minus 1, right? Confused face, like what the Jackie Chan. I mean, I don't know. I feel like this is just one of those days where everything is sad and well, like 4, 2. This is right. Then why is this going? All right. Well. Or 3, 2. What? I'm just so confused. Why is this not printing anything, sir? 3, 2. Do I manipulate anything? This should give me an error, right? No. What is this printing? Oh, whoops. I'm just dumb. Okay, well, listen, I am sleep and food deprived. Okay, so, so it goes 14, which is fine. Do we not just do dx? -1 is 14. Okay, 0 is negative infinity. That's true. Oh, it should be +1, right? +1 is 4. But the 14 is on... Okay, I mean, I guess we knew that was happening. We went here. But why is... There should not be 14, though. What is that? 3, 4? 3, 4? Why am I debugging something so silly? 3, 4? Why is there no entry for 3, 4? It's a 5 by 5. 3, 2. 3, 2. So no, that's not 3, 4. That is 2, 2, 3. No, 2, 4, 2, 4. Sorry. Also no 2, 4. Huh. Because basically it tries to do this, which is fine, and then it goes to Why am I being so dumb on this? I don't get it. 3 2 goes to 2 3. Right, 2 3. Okay, what is R 2 3? 2 3 is 14 Y. Okay, so that's the Y. 2 3. It goes to, oh, because best is equal to 0. Oh man, Larry. Okay, I mean that's fine. I'm just having a rough day, clearly. Silly defaults. I choose negative infinity and I ignored it. Okay, I mean, yeah, okay, fine. Conceptually, I could have gotten it, but I guess today's just not my day. I mean, okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Hit the like button, especially to give me a little support for this poll contest. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.